Preparation of hydrogen. Preparation of hydrogen is studied under two headings: laboratory methods and industrial methods. Laboratory methods means we will prepare hydrogen on a small scale in the laboratory. Industrial methods means we will prepare hydrogen on a large scale for the purpose of industries. Now let us discuss laboratory methods. Under the heading laboratory methods, the first method is by the action of water on metals. We have to consider highly reactive metals like alkali metals and alkaline earth metals. When they are made to react with water, hydrogen is liberated. For example, let us consider sodium. When a piece of sodium is dropped in water, a highly vigorous reaction will take place. Almost all explosion will occur, and the products formed are sodium hydroxide and hydrogen gas. Sodium hydroxide will be in aqueous solution and hydrogen is liberated in the form of gas. For balancing, let us put half here. Similarly, we can consider alkaline earth metals also. For example, consider calcium. When calcium is made to react with water, it forms calcium hydroxide and hydrogen. Hydrogen is liberated in the form of gas. For balancing, here there are two oxygens, put 2 here, 2 2s are 4 hydrogens, hydrogens are balanced. So alkali metals and alkaline earth metals, when they react with water, hydrogen gas is liberated. Now second method, by the action of dilute acids on active metals. Here we are writing the word active metals. What are active metals? Active metals are the metals which are present above normal hydrogen electrode in electrochemical series. In electrochemical series, we come across this electrochemical series in electrochemistry chapter, and in that list all the metals which are present above normal hydrogen electrode are called active metals. They are highly electropositive metals. Some examples of active metals are 1A group elements, that is lithium, sodium, potassium, rubidium, cesium, francium. 2A group elements, beryllium, magnesium, calcium, strontium, barium, radium, zinc, aluminium, iron. All these are etc. All these are active metals. These are present above normal hydrogen electrode in electrochemical series. Now, when these active metals are made to react with dilute acids, hydrogen gas is liberated. Let us write some examples. From the alkali metals, let us take sodium. When sodium is made to react with dilute HCl, it will produce sodium chloride and hydrogen H2. For balancing, put 2 here, 2 chlorines, 2 sodiums. Therefore, hydrogen is liberated in the form of gas. Second one, this time let us consider aluminium. When aluminium is made to react with dilute hydrochloric acid, it will form aluminium chloride and hydrogen gas. Hydrogen is liberated in the form of gas and aluminium chloride will be in aqueous solution. And here if we balance, there are 3 chlorines and there are 2 hydrogens. Therefore put 6 here, 2 and 3. 3 2s are 6, 3 2s are 6, 6 6 balanced. So anyway, hydrogen gas is produced. Now this time let us consider zinc. When zinc is made to react with dilute HCl, here also reaction will take place. Zinc chloride salt is formed and hydrogen gas is liberated. For balancing, put 2 here. Hydrogen is liberated in the form of gas. So in all these reactions, hydrogen gas is liberated. But generally granulated zinc is used. That implies we will use this reaction more frequently for producing hydrogen. And that zinc will be in the form of granulated zinc. Granulated zinc means some spherical pieces. Granulated zinc is used to produce hydrogen gas. Very important point, which is used generally for producing hydrogen gas, granulated zinc. Now let us write the third point. By the action of alkalis on amphoteric metals, hydrogen gas is produced. What are amphoteric metals? Amphoteric metals means the metals which can react with both acids and bases. Those are called amphoteric metals. When an alkali is made to react with these amphoteric metals, hydrogen gas is liberated. The general examples of amphoteric metals are zinc, aluminium, tin, etc. Now let us write equations. Here we have sodium hydroxide. It is an alkali, aqueous sodium hydroxide solution, and into this we are adding zinc. Zinc is an amphoteric metal. Then we will get a substance with the formula Na2ZnO2. Along with this we will get hydrogen gas. The name of this compound is sodium zincate. Sodium zincate, and hydrogen gas is produced. For balancing, put 2 here. 2 sodiums, 2 oxygens and 2 hydrogens are balanced. Again, here we have another amphoteric metal. It is aluminium. When aluminium is made to react with sodium hydroxide, it will form NaAlO2 and hydrogen. This NaAlO2 is sodium aluminate. Sodium aluminate. Therefore, sodium aluminate along with hydrogen gas is produced. For balancing, because there are 2 oxygens, put 2 here. 2 sodiums balanced. And here we should write one H2 also, because there is oxygen and hydrogen. We have to write H2O. Then there are 3 hydrogens, therefore put 3/2 here. Okay, so sodium hydroxide is reacting with aluminium in the presence of water to form sodium aluminate and hydrogen gas. Anyway, hydrogen gas is produced. So till now we have studied 3 methods. Number 1, by the action of water on highly reactive metals like alkali metals and alkaline earth metals, we can produce hydrogen gas. Second one, by the action of dilute acids on active metals. Third one, by the action of alkalis on amphoteric metals. All these are laboratory methods. We have one more laboratory method. By the action of water on ionic hydrides, hydrogen gas is produced. What are ionic hydrides? Ionic hydrides are the compounds formed by alkali metals and alkaline earth metals in which ionic bond is present. For example, consider sodium. Sodium reacts with hydrogen to form sodium hydride. In this compound, it will have Na plus and H minus. Na plus is cation and H minus is anion, and they are bound together by ionic bond. Ionic bond. Such compounds are called ionic hydrides. So I repeat once again, what are ionic hydrides? Ionic hydrides are the compounds in which ionic bond is present in between a metal and hydrogen. Here hydrogen will act as H minus, that is anion. Okay, let us write one more example. Consider calcium hydride. What does calcium hydride contain? Ca plus 2 ions and 2 H minus ions. Ionic bond is present between them, so it is an ionic hydride. Now here the point is, when ionic hydrides react with water, hydrogen gas is liberated. Let us see the examples. Consider sodium hydride, NaH. It is made to dissolve in water. This is a solid, it is dissolved in water. Then immediately sodium hydroxide and hydrogen gas is produced. Here there are 3 hydrogens. Here also there are 3 hydrogens. Everything is balanced. So hydrogen gas is produced. Similarly, let us consider calcium hydride. Calcium hydride, when it is dissolved in water, it will produce calcium hydroxide and hydrogen gas. Here there are 2 oxygens, put 2 here, 2 2s are 4 plus 2 6. Here 2 hydrogens are there, so put 2 here. Anyway, hydrogen gas is produced. All these are laboratory methods. What is the 4th one? By the action of water on ionic hydrides. Some examples of ionic hydrides are sodium hydride, calcium hydride. Okay, now let us start industrial methods. Under the heading industrial methods, the first example is electrolysis of water. We know that water on electrolysis liberate hydrogen gas and oxygen gas. First of all, what is electrolysis? Electrolysis is nothing but decomposition of a compound in the presence of electricity. Decomposition of a compound in the presence of electricity is called electrolysis. Okay, now here we are doing the electrolysis of water. In order to perform the electrolysis, we should use electrodes. Here the electrodes are made up of platinum electrodes, and we should pass electricity. Then this water will be decomposed into 2 gases, hydrogen gas and oxygen gas. Hydrogen gas, oxygen gas. For balancing, put half here. You know the reaction vessel used for electrolysis. It is nothing but a beaker, and here we have to take the solution and we will place 2 electrodes and we connect them to the terminals of a battery. The one which is connected to the positive terminal is called anode. The one which is connected to the negative terminal is called cathode. Here in this example, a hydrogen gas is liberated at cathode and oxygen gas is liberated at anode. Okay, now the thing is, if we take pure water, it will not conduct electricity. Pure water do not conduct electricity. So what we should do is, we have to do the electrolysis in the presence of an electrolyte. Generally, for the sake of electrolyte, we will use an acid or base. Okay, we have to use one acid or base. Suppose if you use barium hydroxide as the electrolyte. What is barium hydroxide? BaOH taken twice. If you use barium hydroxide as the electrolyte and if you do the electrolysis, the most important thing is we will get a pure hydrogen. Pure hydrogen gas is obtained. This is a very important point for objective questions. Here, what is the best method to prepare pure hydrogen? The answer is electrolysis of barium hydroxide solution. But one more point is, we have to do the electrolysis in this case with nickel electrodes, then we get pure hydrogen. So I repeat the point once again. What is the best procedure to produce pure hydrogen? Answer: electrolysis of aqueous solution of barium hydroxide with nickel electrodes. Then we get pure hydrogen gas. Pure water does not conduct electricity. Therefore, we have to mix some electrolyte. If we use barium hydroxide as the electrolyte, then we can get pure hydrogen. Okay. First method is completed. Now we are starting the next method. It is called coal gasification. Coal gasification is also called as Bosch process. Let us see the reaction. Steam is passed over red hot coke. Steam is passed over red hot coke or coal to get carbon monoxide and hydrogen gas. This reaction is called coal gasification. First of all, what is coke and what is coal? Coal and coke both are raw materials which contain carbon. Both of them contain carbon. But the thing is, coke contains more percentage of carbon, coal contains less percentage of carbon. These are the allotropic forms of carbon. Both of them contain carbon. Here it will have more percentage of carbon, coal will have less percentage of carbon. And we have to take both of them or any of them in red hot condition. The meaning of red hot condition means it is at higher temperature. Onto this red hot coke or coal, we are passing steam. What is meant by steam? Steam is nothing but water vapor. The minimum temperature of steam is 100 degrees. But this time, here because we are in red hot condition, the temperature is going to be 1000 degrees. So we are going to pass the steam at 1000 degrees Celsius. So let us write the reaction. Red hot coke or coal. Coke or coal. Onto this we are passing steam at 1000 degrees Celsius. Then we get a mixture of carbon monoxide and hydrogen. Here both of them are balanced. Carbon monoxide is a gas, hydrogen is a gas. That implies we are getting a gaseous mixture. That gaseous mixture is called water gas. So what is water gas? Mixture of carbon monoxide and hydrogen is called water gas. Okay. This is called coal gasification. Why? Because we have converted the coal into gas. That is why it is called as coal gasification. Actually we are trying to get hydrogen gas, but here we got a mixture of carbon monoxide and hydrogen. Anyway, hydrogen gas is obtained. This is called coal gasification. Sometimes hydrocarbons on treating with steam also produces carbon monoxide and hydrogen gas. The process of obtaining hydrogen from natural gas is known as steam reformation process. Here what we are learning is, even from hydrocarbons also we can obtain carbon monoxide and hydrogen. In the previous reaction we got carbon monoxide and hydrogen from coal or coke, but this time we are going to take hydrocarbon. Hydrocarbon, one example is CH4. What is this CH4? Methane. The main component present in natural gas is methane. Indirectly we are using natural gas because natural gas majorly contains methane. Now what we should do? This methane is treated steam high temperature. Then now also carbon monoxide and hydrogen gas is produced. Now let us do the balancing. Here there are 4 hydrogens and 2 hydrogens, 6 hydrogens, therefore put 3 here. 3 2s are 6. Hydrogen gas is produced. carbon monoxide is also produced. This mixture of carbon monoxide and hydrogen is called water gas. This process of preparing hydrogen from natural gas, that is methane, is called steam reformation process. Okay. Now here there is an important point. Water gas is also known as syngas or blue gas. Let us write the reason for this. I repeat once again. Mixture of carbon monoxide and hydrogen gas. Carbon monoxide gas, hydrogen gas. This mixture is called water gas. There is another name for water gas. What is it? Syngas. Why is it called syngas? Because by using this water gas or COH2 mixture, by using this mixture, we can prepare many number of organic compounds. That is why it is called synthesis gas. Because we can prepare many organic compounds, it is called synthesis gas. That synthesis gas is also called as syngas. It is also called as blue gas. Why is it called blue gas? Because it burns with a blue flame. It burns with blue flame. Why? Because carbon monoxide burns with blue flame. Hydrogen gas also burns with blue flame. The total mixture also burns with blue flame. That is why it is called blue gas. So the other names of water gas are syngas and blue gas. So with this we have completed one process. What is the process? Production of water gas. In that water gas we are having hydrogen. The first process is coal gasification. The second process is steam reformation process. Both these methods can give water gas. Now the question is, how to get hydrogen gas alone? We are having a mixture of carbon monoxide and hydrogen, but how to get the hydrogen gas alone? That implies how to separate this carbon monoxide. For separating this carbon monoxide, we have a process called quenching. What is quenching? Sudden cooling. During this process, carbon monoxide gets liquefied and hydrogen gas remains as gas only. I will explain you the reason. Consider carbon monoxide, C triple bond O. Consider hydrogen molecule, H single bond H. Here both of them are hydrogen atoms, same electronegativity. Therefore, this is a non-polar molecule. Carbon monoxide, carbon is less electronegative than oxygen. Therefore, oxygen gets partial negative charge, carbon gets partial positive charge. Therefore, it is a polar molecule. So, carbon monoxide is a polar, H2 is a non-polar. We know that polar molecules have dipole-dipole attractions. Therefore, they get liquefied very easily. Therefore, when these two are subjected to cooling, sudden cooling, what happens? This carbon monoxide gas will convert into liquid, but hydrogen will remain as gas. Why? Because hydrogen is non-polar. It won't get liquefied easily. Therefore, carbon monoxide is converted into liquid, it is separated, and we are going to collect the hydrogen gas. That's how hydrogen gas is separated. Okay. That is one important point, quenching. Now we have another point. It is a separate point. In order to increase the production of hydrogen gas, water gas shift reaction is used. This is a separate point. Don't get confused with the above things. In order to increase the production of hydrogen gas, water gas shift reaction is used. I will explain you here. Here we are having water gas. We obtained water gas by coal gasification. What is it? Mixture of carbon monoxide and hydrogen. This is the water gas. Now in this water gas, we are having hydrogen 1 mole. Now you want to increase the amount of hydrogen. Then what we will do is, we will perform water gas shift reaction. What is meant by water gas shift reaction? We will heat the water gas with steam. What is the catalyst used here? It is Fe2O3 in the presence of chromium. Simply we will call this mixture as iron chromate. So in the presence of iron chromate, steam is passed into the water gas at high temperature. Then what happens is, a reaction will occur. Carbon monoxide will take this oxygen and converts into carbon dioxide, and H2 and H2, both of them will be collected as H2. So CO is oxidized to CO2 and H2O is reduced to H2. Now how many moles of H2 is obtained? 2 moles. So anyway, carbon dioxide gas and hydrogen gas are produced. The interesting thing here is, here we have 1 mole of hydrogen, but here we have 2 moles of hydrogen. That implies amount of hydrogen is increased. So to increase the production of hydrogen gas, water gas shift reaction is used. This is called water gas shift reaction. Okay. I repeat once again. Here we have 1 mole of hydrogen. Here we have 2 moles of hydrogen. That implies the amount of hydrogen is increased. That implies water gas shift reaction is helpful to increase the amount of hydrogen. Now once again we face the same problem. Here we have separated carbon monoxide by cooling. Now here, how to separate this carbon dioxide? Here we have carbon dioxide. How to separate this? In order to separate this carbon monoxide, we do a process called scrubbing. Scrubbing with sodium arsenite. Scrubbing with sodium arsenite is done. Sodium arsenite is NaAsO3. By scrubbing with sodium arsenite, carbon dioxide gas is removed. CO2 gas is removed, then we will have only hydrogen gas. This is called water gas shift reaction. So with this we have completed the second method under the heading industrial methods. Now the third one is, as a byproduct during Nelson's process to prepare chlorine gas. Let us learn this process, Nelson's process to prepare chlorine gas. In that Nelson's process we use brine solution. What is brine solution? Aqueous sodium chloride solution is called brine solution. What does aqueous sodium chloride solution contain? It contains Na plus ions, Cl minus ions and water molecules. Aqueous sodium chloride solution contains all these things. Now in this Nelson's process we perform electrolysis. You know that in electrolysis there will be 2 parts, reaction occurring at anode and a reaction occurring at cathode. Let us write both of them. Reaction occurring at anode, reaction occurring at cathode. Anode is positive electrode. Towards anode the negative ions get attracted. Here Cl minus is the negative ion. It got attracted towards the anode. We know that at anode oxidation will occur. Oxidation will take place. So Cl minus will get oxidized into Cl by the loss of one electron. But Cl cannot stay as Cl, it will be Cl2. Therefore put 2 here and again 2 here. So anyway chlorine gas is produced. So chlorine gas is produced in Nelson's process. That's completed. Now let us write the reactions at cathode. At cathode, reduction should take place. Cathode is negative electron. Towards cathode, the positive ions will be attracted. Therefore Na plus ions approach the cathode. But the thing is, these Na plus ions in aqueous solution do not get reduced. They do not get reduced. No reduction will take place. They will stay as Na plus only. In the place of Na plus, water will get reduced. That implies H2O plus electrons gives OH minus plus H2. For balancing, put 2 here, 2 2s are 4, 2 hydrogens 4, and 2 minus, put 2 here. In the place of sodium, water is getting reduced and OH minus ions and hydrogen are produced. Here the Na plus is present and here OH minus is present. These two will combine and form NaOH. They will get precipitated as NaOH. Here we are getting hydrogen gas. So let us write down all which are obtained. Number 1, we got chlorine gas, no doubt. Number 2, we got sodium hydroxide, no doubt. And we got hydrogen gas also. So in Nelson's process, these 3 substances are obtained: chlorine gas, hydrogen gas and sodium hydroxide. Therefore hydrogen gas is obtained in Nelson's process as a byproduct of chlorine. So anyway hydrogen gas is obtained. So with this we have completed the industrial methods of preparation of hydrogen. What are the methods? Number one, electrolysis of water. Number 2, coal gasification. Number 3, Nelson's process. So preparation of hydrogen is completed. Now let us close this video with another topic. It is about transportation of hydrogen. Transportation of hydrogen. What does it mean? We have to send hydrogen gas from one place to another place. Generally we send gases from one place to another place through cylinders. Now we have a problem to do this process. Let us learn the problem. Hydrogen gas is the lightest gas. Why is it lightest gas? Because it has H2 molecules. Their molecular weight is only 2 AMU. It is a lightest gas. Generally, in order to send gases from one place to another place, we convert them into liquid. For example, we all know LPG. What is LPG? Liquefied petroleum gas. We use this in kitchen. That implies our cylinder will have liquid. It is liquefied petroleum gas. Therefore, also we can convert the hydrogen gas into liquid and transport it through cylinders. But we face a problem here. The problem is, it is having very low critical temperature. When the critical temperature is very low, it will become difficult to be liquefied. It cannot be easily. Therefore, hydrogen gas cannot be converted into hydrogen liquid easily. When we are not able to convert this into liquid easily, we cannot transport it from one place to another place through cylinders. Therefore, transportation of hydrogen has become a problem. In order to rectify that problem, we are having 2 options. Number 1, we can do the transportation of hydrogen in the form of hydrolith. What is hydrolith? Calcium hydride is called hydrolith. What is its nature? When water is added to this hydrolith, hydrogen gas is produced. Let us write the reaction. CaH2 hydrolith, calcium hydride. It is made to react with water to form calcium hydroxide and hydrogen gas. So anyway, hydrogen gas is obtained. For balancing, put 2 here and again 2 here. So by passing hydrolith, we can get hydrogen gas. So transportation of hydrogen is done in the form of hydrolith. Number 2, the transportation of hydrogen is done in the form of anhydrous ammonia. What is meant by anhydrous ammonia? We know that ammonia is NH3. Sometimes it will have some moisture. If you remove that moisture, it will be called as anhydrous ammonia. Now this anhydrous ammonia is subjected to cracking. What is meant by cracking? Heating at high temperatures. Then it will produce N2 plus H2. For balancing, put 2 and 3 here. So anyway, hydrogen gas is also produced. Therefore, the transportation of hydrogen is done either in the form of hydrolith or in the form of anhydrous ammonia. In both the cases, we can get hydrogen gases separately by separate reactions. So in this video, we have completed preparation of hydrogen gas and transportation of hydrogen gas. In the next video, we are going to discuss the physical and chemical properties of hydrogen.